graphing polynomials. Yesterday we didn't actually get to the graphing part. Today we are, obviously, graphing calculator. Today we're talking about the graphs of polynomials and the couple things we have to talk about with them. One key feature of graphs that we're going to be talking about is what's known as the end behavior. End behavior is what happens on the far ends of the graph, or what the graph does, or what a graph does. As x approaches infinity or negative infinity. Now, since we are establishing what x is approaching, what we're going to be looking for is what y is doing. Where is y going? On the far left, which would be when x is approaching a negative infinity, and the far right, which is what happens as x is approaching a positive infinity on the graph. So this is going to be some of the key things that we're looking at today with our graphs. Is what is y doing as x is going to infinity and to negative infinity, as it's going to the far right and to the far left. Ooh, one other thing you might want today is a couple different colored highlighters. If you do not have highlighters, I have highlighters over there.
I happen to know this already. Stole some. I didn't have.
That doesn't mean you get to take them home with you. They're mine. You get to borrow, not steal. Grab highlighters if you don't have them. Give them back afterwards.
How many colors should we?
Doesn't matter what colors, just make sure they're two different colors you can tell apart.
I guess so. Yes.
I can't believe you, Mitchell.
Okay. Use a calculator to sketch the following and describe the end behavior. Now, we're going to actually wait a tiny bit on the highlighters. They have a purpose. You're not going to see it right away. That's okay. I promise. It's there. Because first thing we're going to get to is we're going to get to sketching that graph and talking about that end behavior. Now, as we sketch our graph, I am not looking for the graph to be perfect because it is a sketch, but I am looking for things to kind of be in the right spot. X-intercepts should be around where the x-intercepts are on your graph. Y-intercepts should be about accurate as well. So should any high points and low points. By the way, those are called relative minimums and relative maximums on the graph. So, first equation, f of x is equal to x cubed minus 2x Where's my graphing menu on my calculator?
Right.
Depends upon your calculator. If you've got a TI, top left. If you got a Casio, where are you going?
No clue.
We should know by now. Menu. Graph. Okay, we type our equations in. X cubed minus 2x. Where's the X button? Should be next to your alpha button. If you've got a TI, it's to the right of it. If you've got a Casio, it's below it. If there's anything in there, I'm going to delete it off. X to the power of 3 minus 2x. Why am I not putting the f of x into my calculator?
Because it's already there.
It's already there. F of x is a fancy way of saying y. Is your calculator say a bunch of y equals? If it doesn't, you've got a problem. Once I've got it typed in, how do I actually graph it? Casio, make sure you click enter so that it's no longer trying to get you to write an equation, and you click draw. On the TI, click graph. My graphs look like this. What if your graph looks nothing like that?
You did something wrong.
You did something wrong, or mine looks like that. I just changed mine, but I promise I didn't change the equation. What's the other thing that could be an issue on your calculator? Your zoom, your screen that it's showing you. On a TI, zoom, and which option do you want? Nope, not in or out. Standard. 90% of the time that'll work. You can zoom in and out from there, but I would go to zoom standard first. On the Casio, how do I get to a standard zoom? It's not zoom, actually. It's viewing window. And F3 is standard. Okay. My graph looks something like this. I make my XY axis. I try to make the important parts kind of around where they're supposed to be. Now I could do that a couple different ways. I can either use the tick marks to help me, or I can label the points after I've graphed it. I personally like the tick marks. This point here appears to be at like -1, 1. It appears to hit the origin. It appears to hit +1, -1. Okay, so it appears to hit a point there. It appears to hit a point here. It appears to hit a point like here. Before that, it kind of goes up and curves. And then it goes up again. That's the sketch of the graph, but now I need to talk about end behavior. There are 2 end behaviors for every graph, as x goes to -infinity and as x goes to positive infinity. This notation means as x goes to -infinity. And then a couple lines below that, giving myself some space between them, I also want as x goes to infinity or positive infinity. Which axis is the x-axis?
Vertical.
The horizontal one. Where does the x-axis get closer and closer to -infinity? Does he go which direction? So you move to the left. So I am looking to the left to figure out the first one. Specifically, I'm looking at where y goes. My graph appears to go downwards and downwards and downwards and downwards. Would you agree with that?
Yes.
What number is y getting closer to?
-infinity.
Y values are up and down. Up is positive infinity, down goes towards negative infinity. Since it's going indefinitely down, the y, or the f of x, I don't care which way you put it, you can put it as y, you can put it as f of x, but it, in this case, is going to negative infinity. I'm going to look at the same thing on the right side of my graph. As my x's are getting bigger, in other words, as I'm going to the right on my graph, where are the y values getting closer to? Positive infinity. It's going up indefinitely. It's going towards infinity. Positive infinity.
Do we have to say positive?
If you just write infinity, I will assume it's a positive infinity. Okay? That's the sketch and the end behavior. What do you think you should do first? Plug it into your y equals in your calculator. Mine looks like that. How about your guys's? What are some important points the graph appears to hit? That should probably be accurate. -1, negative, probably a little bit shy of 3. Good. The origin. +1, positive, almost 3 again. On your axis, if you're counting by more than ones, you need to put numbers. If you don't put numbers, I'm assuming you're counting by ones. Okay, it appears to hit like right here-ish, and right here-ish. The rest of it, I just kind of make it look right. Ooh. What about its x-intercepts? Where does it appear to hit? Bit left of -1, a bit right of +1. I accidentally got a little lazy on the last one and missed that. As x approaches negative infinity and as x approaches positive infinity. As x approaches negative infinity, where am I looking on my graph?
Left.
Towards the left. As I move left on my graph, what is the up and down doing?
Up.
Going up indefinitely. In other words, the y's are getting closer to what? Going up forever gets closer to
Positive infinity.
a positive infinity. For x going to infinity, I'm looking to the right. As I go to the right on my graph, what's happening with the up and down now?
It's going down.
Going downwards. Towards negative infinity. I'm going to have you try these couple out on your own. look something like this. Does yours look like that? Now, I do not care if you talk about going to positive or negative infinity first with x. You just have to know which one is which. If I go to positive infinity, am I looking towards the right or to the left of my graph?
Right.
To the right, because this is where x's are getting bigger. It's positive infinity. As I'm moving to the right, what's y doing?
Up.
It's going up. The y values go either up or down. Up is positive, down is negative. As x is going to negative infinity, which direction am I looking on my graph?
Left.
Moving to the left. And I'm paying attention to where y is going. As I move to the left, what is y doing?
Up.
It's also going up. Because as I move this way, the graph's going this way. Okay. The other one that we've got here. Looks like that. As x is going to negative infinity, which way is y going?
Down.
Down, which is towards negative infinity. As x is going to the right, y is going to negative infinity as well. Now, I purposely chose these 4 problems to talk about something else with their graphs. Do you notice that the first 2 have one side going up, one side going down?
Yes.
Any thoughts as to why that might be? Yep.
Because their degree is odd.
Yes. It's because they have an odd degree. What is the degree of the first one? 3. What's the degree of the second one?
5.
Odd degree functions. One will go up, one will go down. If the degree of the polynomial is odd, they will go in opposite directions. If the degree of the polynomial is even, they will go in the same direction. That's why both of the bottom ones, which have degree 4 and degree 2, either both go up or both go down. Other things to notice. This one ended going up, this one ended going up. This one ended going down, this one ended going down. Any guesses as to why, if the negative in front or not? The leading coefficient being positive or negative tells you the right end behavior. As x goes to infinity, y will also go to infinity. While if it has a negative leading coefficient, as x goes to infinity, y will go to negative infinity. Okay. There's one more key thing I want to look at when it comes to these graphs, and that's why I had you grab highlighters. Mitchell.
Yeah.
Rose. Nathan. Just making sure people are awake.
No, we're not.
This is what I'm calling you out on.
Oh.
The other thing I want to take a quick look at is where the graph is increasing versus decreasing. I'm going to make increasing orange. I'm going to make decreasing green. To read increasing or decreasing is like reading positive versus negative slope. You always read a graph from left to right. So that means I start over here on my graph because this is where it is the farthest to the left on my graph. Is the graph going up or down? It's going up. Where does it stop going up? It's still going up? No. It stops going up once it reaches a high point, also known as a relative maximum. That's increasing. All of a sudden after that it's decreasing. Where does it stop decreasing? When it gets to the relative low point, the relative minimum. After that it goes back to increasing. How many different directions is this graph going? Let me rephrase. How many different sections? Three are there. There's 3 sections. Think that has something to do with anything? Has to deal with that degree. Now, is it always going to match perfectly? No. But it tells you the maximum number of sections of increasing and decreasing it can have. This one is an exception to the rule. Does it start off increasing or decreasing? Decreasing. After decreasing, it goes to increasing. And then back to decreasing. Now this one only has 3 sections. But the number of changes it can have is maximized by its degree. It's not always exactly, but it's maximized by that number. This one here, does it start off increasing or decreasing? Decreasing. Until it reaches a low point. After that, it goes increasing till it reaches a high point. It changes again to decreasing. And then it changes again to increasing. How many different sections did it have? 4. Did it maximize its number of sections? Yes, because its degree was 4, it's 4 sections. The last one went from increasing to decreasing. 2 sections, maximum number of sections. Now the increasing, decreasing is not going to be emphasized today in the homework. It's something I need to point out because it's going to help us in the future. But we're not going to get too uppity on that yet. Same thing with that odd and even, positive versus negative leading coefficient. They're good things to know, but if you can look at the graph and tell me the end behavior, that's the things we're focusing on right now. Page 158, day 2, numbers 19 through 30.